In this video, I'm just going to provide some solutions to parts E and F of question 1 from the lab exercises in week 10. Previously, we've been looking at an F test of the significance of a model for the demand for beer. Now, in part E, we're going to look at a different kind of hypothesis test and using the F statistic, and then looking at actually estimating that equation, assuming that a restriction was actually imposed on it. So we're going to estimate a restricted model as the final part. Part E says, economic theory suggests that if all prices and income go up by the same proportion, there should be no change in quantities demanded. This is essentially saying that there are no money illusions, that people are rational and able to recalculate that if all prices and income go up by the same proportion, that essentially relative prices have not changed, and hence their demand for goods and services will not change either. If this is true, the question tells us we should find that the sum of all the slope coefficients is equal to 0. And we're asked to test this hypothesis using e-views. Well, I'll go to my unrestricted model that we had calculated previously. And now I want to go to View and Coefficient Diagnostics, Wold Test, which is the way that we'll do our hypothesis tests in eViews. And now I just need to type in that restriction using eViews syntax. So that would be C2 instead of B2, plus C3 instead of B3, plus C4 plus C5 is equal to 0. That's our null hypothesis, which is termed a restriction here. I'll hit OK, and eViews runs this hypothesis test for us. I'm going to freeze that output, which means take a copy of it, and then give it a name. I'll call this just test. Maybe test 2. And you can see that this test, because we're only imposing one restriction on the model, can actually be done in the form of a t-test or an f-test. So here's the t-test being conducted, and the f-test is essentially equivalent to the t-test, and you can see that is why they both come up with the same p-value. Although, because we're taking a different perspective on the restriction in the two different forms of the test, there are different test statistics for them. Okay, so there's our output. What do we actually make of it? The question, part 2 here of E, says what conclusion will be drawn for this test at a significance level of 5%. So we have a p-value of 0.1266. This is greater than our significance level, and that means that we will be unable to reject the null hypothesis. So we can't reject the null hypothesis there. That suggests that our data is compatible with this hypothesis, that there are no money illusions in the demand for this particular product. Part F says, okay, now that it seems as though this assumption has some empirical support, what would happen if we actually estimate an equation which we forced to comply with this particular restriction? To do this, we're going to go into Quick and Estimate Equation, and previously we would have specified the equation in a form like this: log of P price of beer, log of price of other alcoholic beverages, log of the price of remaining goods, and the log of income. If we want to estimate a restricted model, we have to change the way this specification is done a little. I'll show you how to do that. Rather than, so I'm now going to put an equal sign in there, not just use spaces. I'm going to call this C1, which is coefficient 1, our B1, then C2 times the log of our first explanatory variable, the price of beer, plus C3 Okay, so if I were to hit OK now, I should actually get the estimation output that is identical to what we had previously. So just I'm going to show that I'll hit OK. Here is our estimation, and I'm going to compare that to the original model that we estimated. Here it's showing us a view of a hypothesis test, but I'm going to go and view the estimation output, and you can see that these coefficients and standard errors are all identical. So going back to estimate, this specification was exactly the same as what we were doing previously, but at this point I haven't imposed that restriction on the model. To do this, I need to rearrange the restriction to get so that it has one of the coefficients. I can substitute out or remove one of the coefficients from this model, and I'm just madly scrambling to see which one I decided to eliminate in the example in the notes from workshop 10. And I've turned to page 5, where it sort of steps you through this estimating a restricted model. And I chose to eliminate this beta 4 or coefficient 4 when I was estimating the restricted model. So I'll do that again. This just requires me to manipulate the restriction, which was B2 plus B3 plus B4 plus B5, to get B4 by itself. If I do that, I find that B4 is actually equal to negative B2, take away negative B3, take away negative B4, take away beta 5, because it was beta 4 that I was trying to find here. Okay, so that restriction there from the null hypothesis has just been rearranged to give us this coefficient, which has replaced C4. I'm now going to estimate that equation, and there are our restricted least squares estimates. Notice that there is no C4 there, but I do know that C4 is equal to negative C2, take C3, take C5, so I can easily calculate it. And in fact, let me just do that up here. I'll save it. Now, immediately after estimating an equation, you can access the estimated coefficients in this way. So negative, to access the coefficient at C2, take away at C3, take away at C5, so I didn't actually need the at symbol there. Those values are accessed simply by using C2. Now I will go back and have a look at what I just saved, which was B4. 0.166742. If you have a look at the figures that are provided on page 5 of the week 10 workshop notes, you'll find that that is the figure shown there, and these other coefficients that we've estimated are the same as those that are listed. And of interest to us is that how these coefficients compare to the model that we originally estimated. Let's have a very quick look at that. This was the unrestricted model. There it is there. Okay, so we can't directly compare this coefficient, but if we have a look at all of these others, we'll find that there is some difference in our estimates, and also of interest, the standard errors are different. Now this restricted least squares should actually mean that the standard errors we come up with are a little bit lower than those that we came up with the unrestricted model, because imposing the restriction allows for less variation in the estimates that we come up with here. And I'll allow you to have a look at those, but I can see directly here that C2 has gone down noticeably in our restricted equation estimate. C32 has gone down considerably. Okay, we'll finish there.